Switch security configuration topology. Use router 4321 packet tracer switch for S1 2960 switch and also for S2 two PCs and R1, S1, S2 dash A dash B. Now connections and from gigabit 001 R1 to Ethernet 5 on S1 between switches Ethernet 1 on both sides, and the connection from S1 use Ethernet 6 to PCA, and from S2 Ethernet 18 to PCB. This is the addressing table. Gigabit 001, IP addresses 10.1, loopback interface on R1. S1 uses VLAN 10. The management interface will be VLAN 10 and IP 10.2 of 1, and S2 VLAN 10, 10.2 of 2. PCA and PCB using the HCP. Required resources on real lab 1 router 4221, 2 switches 2960, 2 PCs, console cables, Ethernet cables. Configure the network devices, cable the network, ready. Cable, initialize the devices. Okay, on real lab, on R1 you need to erase the startup config, then reload. And on real lab on switches, erase the startup config and delete the VLAN database and reload. Configure R1. Load the following configuration script on R1. Okay, copy all this. Okay, I prefer to paste first on Notepad and review. Okay, enable to go from user exit mode to privilege exit mode. Configure terminal to go global configuration mode and set the hostname, no IP domain lookup. Exclude addresses for DHCP pool. Okay, R1 will be a DHCP server. Interface loopback 0. The IP address gigabit 001. Description IP DHCP relay information trusted. Okay, packet tracer does not support this command, but I will do it anyway. And IP address 10.1, no shutdown, and line console configuration. Okay, go to R1 command line interface. Okay, would you like to enter initial configuration dialog? No. Enter. Okay, user exit mode and copy this. Okay, enable configure terminal hostname. Okay, copy, paste. Okay, very good. Enable configure terminal hostname, IP domain lookup, excluded addresses, DHCP pool, loopback 0, gigabit description, and packet tracer does not support this command, IP DHCP relay. Okay, but don't worry, DHCP server will work very good. And IP address, not shut down, line console, very good. And continue with verify, show IP interface brief. Okay, go to privilege exit mode and show IP interface brief. Enter. And gigabit 00, IP address status up, protocol up, loopback 0, IP address status up, protocol up. Very nice. Verify IP addressing and interfaces are in up state. Okay, up, 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 up. Very nice. So configure and verify basic switch settings. Hostname on S1 and S2. Okay, go to S1 for example. Command line interface, enter. Enable to go privilege access mode, configure terminal to go global configuration mode, and set the hostname for S1. Hostname S1, enter. Now, prevent unwanted DNS lookups. No IP domain lookup, enter. Configure interface descriptions for the ports that are in use in S1 and S2. Okay, only descriptions. For example, Ethernet 5 on switch S1. Interface Ethernet 5. You are on interface configuration mode. Description. You can say connection to R1. Enter. Okay, you can use any description, any label. It's only a label. Ethernet 6. Connection to PCA. Ethernet 6 connection to PC-A. And Ethernet 1 connection to S2. Ethernet 1 connection to S2. Okay, only descriptions, only informational, and exit to go global configuration mode. And set the default gateway. For the management VLAN to 192.168.10.1. Okay, IP default gateway 192.168.10.1. Enter. The same procedure on S2. Enter, enable, configure terminal, hostname, S2. No IP domain lookup. Interface. Ethernet 1 connection to S1. Ethernet 1 description connection to S1. Ethernet 18 connection to PCB. Ethernet 18 connection to PC-B. Enter, exit, and the default gateway on global configuration mode. IP default gateway. Okay, gateway 192.168.10.1. Enter. Configure VLANs. Configure VLAN 10. Configure VLAN 10. VLAN 10 to S1 and S2. The name is management. Okay, S1. VLAN 10 name management. Exit. S2. VLAN 10 name management. Exit. Okay. You are configuring VLAN on global configuration mode and set the name VLAN configuration mode. Then exit to go back global configuration mode. And configure SBI for VLAN 10. Configure IP address according to the addressing table for SBI. Switch virtual interface for VLAN 10 on S1 and S2. Okay, enable the interfaces and provide a description. Go to addressing table and configure on S1 VLAN 10 IP address and subnet mask. Don't forget description and enable the interface. S1 VLAN 10 interface VLAN 10 description management interface IP address 192.168.10.201 subnet mask 24. No, shut down. Okay, exit. Go to S2, interface VLAN 10, description, management interface. IP address 192.168.10.202, subnet mask 24. Now shut down. Exit. Configure VLAN 333 with the name native on S1 and S2. Configure VLAN 999 with the name parking lot on S1 and S2. Okay, first on S1, VLAN 333, name native. VLAN 999, name parking lot. Case sensitive. Parking lot. Exit. S2. VLAN 333, name native. VLAN 999, name parking lot. Exit. Configure switch security. Implement AO2.1Q trunking. On both switches, configure trunking on faceted 1 to use VLAN 333 as the native VLAN. Okay, this will be the trunk link. Is the faceted 1 on both sides. On S1, configure interface faceted 1 switch port mode trunk. Enter. Okay, is switch port mode trunk. Okay, very good. Switch port mode trunk and use VLAN 333 as the native VLAN. Switch port trunk native VLAN 333. Enter and exit. Okay, and now go to S2. But you will see this message. Native VLAN mismatch discovered on faceted 1. Okay. The native VLAN on faceted 1 on S1 is VLAN 333. Okay, but the native VLAN on faceted 1 on S2 is different. The native VLAN by default is VLAN 1. So this message will appear. Okay, so go to S2, enter interface faceted 1, switch port mode trunk, and switch port trunk space native VLAN 333. Enter. And now, once native VLAN is 333, you will see this port consistency restored. Now it's fixed. Very good. Exit, and now you are on global configuration mode. And verify. Show interface trunk. Go to S1, enter, and privilege exit mode. Show interface trunk. Enter. Okay, port faceted 1 mode on static trunk encapsulation AO2.1Q status trunk in native VLAN 333. Okay, on S2 the same configuration and show interface or show interfaces trunk. Okay, faceted 1 mode on encapsulation status native VLAN 333. Disable DTP negotiation on faceted 1 on S1 and S2. Okay, go to S1, configure terminal, faceted 1, and switch port no negotiate. switch port space no negotiate. Enter. Exit. On S2, configure terminal interface for Ethernet 1. Switch port no negotiate. Exit. Okay. Verify show interfaces command. For example, on S1, exit to go privilege exit mode. Show interfaces for Ethernet 1. Switch port pipe. Include negotiation. Enter. And you will see this message, negotiation of trunking off, disabled. With this command, no negotiate. Okay, but try to only show this part, show interfaces for Ethernet 1 switch port. Enter. And on this output, and all this output, you want only this line, negotiation of trunking of, only this line. So that's why you will include the pipe and the include keyword to only show the line with negotiation word. Okay. S2 and show interface for the Ethernet 1 switch port pipe include negotiation. Okay, very nice. Negotiation of trunking of. Configure access ports. On S1, configure Fast Ethernet 5 and 6 as access ports associated with VLAN 10. Okay, on S1, 5 and 6. Remember, 1 is the trunk, so only Fast Ethernet 5 and 6, the access ports. Space, configure terminal interface range. Okay, to select range, to select two ports for Ethernet 5 and 6. Switch port mode access. And assign to VLAN 10. Switch port access VLAN 10. Enter. Exit. On S2, configure Fast Ethernet 18 access port and VLAN 10. This interface, Fast Ethernet 18, Fast Ethernet 1 is the trunking. Configure terminal interface, Fast Ethernet 18. Switch port mode access. Switch port access VLAN 10. Enter. Exit. Very good. Secure and disable unused switch ports. S1 and S2. Move the unused ports from VLAN 1 to VLAN 999 and disable the unused ports. Okay, what ports are in use on S1? 5, 6, and 1. So select all the unused ports with interface range command for Ethernet. 1 in use, so select from 2 to 4. 5 and 6 in use, and select from 7 to 24 and gigabit 0, 1, and 2. And enter. Switch port mode access, switch port access VLAN 999, the parking lot VLAN. And disable the unused ports shutdown. Okay. Exit. Go to S2. What ports are in use on S2? 1 and 18. So select all unused ports. Interface range. What's that? From 1 is in use, from 2 to 17. 18 is in use, and 19 to 24, and gigabit 0, 1, and 2. Enter. Switchboard mode access, switchboard access, and switchboard access bilang 999, parking lot bilang. Shutdown. Exit. Okay, very good. Verify. Show interfaces status. On S1, for example, exit to privilege exit mode. Show interfaces status. Enter. One connected from 2 to 4. Disable. 5 and 6 connected. 7, 8, 9, 10. Disable. Okay, very nice. On S2, exit. Show interface status. Space. Now you will see facade 1 connected. All interfaces, any other interfaces disabled except facade 18 connected. Document and implement port security features. The interface facade 6 on S1 and 18 on S2 are configured as access ports. You will also configure port security on these two access ports. On S1, show port security interface facade 6. To display the default port security settings, okay, go to S1. You will see the security configuration by default on facade 6. Click on S1. Show port dash security interface facade 6. Enter. And now record your answers in the table below. This table port security by default disabled. Maximum MAC addresses only 1. Relation mode shut down. Aging time 0 minutes. Aging type absolute. Secure static address aging disabled. Sticky MAC addresses 0. On S1, enable port security on facade 6 with the following settings. Configure all this, but first enable port security on facade 6. Configure terminal interface facade 6. Switch port security. This command to enable port security. And now maximum number of MAC addresses 3. Maximum 3. Violation restrict. Switch port security. Violation restrict. And aging time 60 minutes. Switch port security. Aging time 60 minutes. 60. Aging type inactivity. Switch port security. Aging type inactivity. Okay. Enter. Packet Tracer does not support this command, but don't worry. And finally, end to go privilege exit mode. Okay, and maximum number of MAC addresses 3. Okay, maximum 3. So on facade 6 on S1, you can connect 3 MAC addresses, maximum 3. If the maximum number of MAC addresses is exceeded, a violation will occur. And in this case, the action is restrict. And this action restrict drops all the packets from the insecure host and increments the security violation count. Okay, this security violation count will be incremented, okay, using restricts, and drops all the packets from the insecure host. Okay, the aging time is 60 minutes. Okay, and sets the duration for which all addresses are secured. One thing to keep in mind is that when port security is activated, MAC addresses do not expire by default. If you want to configure expiration time, you must configure aging time. Aging type inactivity specifies that the timer starts to run only when there is no traffic. Okay. Verify. Show port security interface facet 6. Enter. Now, port security now is enabled. The status is up with secure. Violation mode. Now change it to restrict. Aging time 60 minutes. Aging type should be inactivity because this command was rejected, but on real app should be inactivity. Secure static address aging disabled. Maximum MAC addresses 3. Total MAC addresses 0. With real app should be 1. Last source address no MAC VLAN, no VLAN. Okay, but on real app you should have the MAC address and VLAN. This is the MAC address and VLAN. Okay, MAC address column the number of VLAN 10. But to simulate the real app on PCA, you can generate traffic to R1. Okay, to generate traffic, configure the HCP client on PCA. Now you got the IP, subnet mask, and default gateway from the DHCP server placed on R1. Okay, and I think traffic was generated between R1 and PCA, so you can repeat repeat the command show port security interface facet 6, enter, and now you will see the MAC address on facet 6. This is the MAC address of PCA, and 10 because it's the VLAN 10. Okay, and now total MAC addresses 1. This MAC address 1 PC connected on VLAN 10. Okay. Show port security address. Show port dash security space address. And now you will see VLAN 10 MAC address is this MAC address of PCA and type dynamic configured. Okay, so dynamically learned by the switch. Okay, you only configure it. Enable port security, maximum number of MAC addresses, violation restrict, aging time, and aging type. Okay, dynamically learned, dynamic configured. Ports facet 6. Okay, very good. This interface. And remaining age, no information. Okay, but on real app you should see 60 minutes. Okay, 60 minutes. Okay, Packet Tracer does not show this. because this agent type command was not accepted. Okay. Enable port security on fast Ethernet 18 on S2. Okay, fast Ethernet 18 on S2. Click on S2, enter, enable configure terminal interface fast Ethernet 18. And now configure the port to add MAC addresses learned on the port automatically to the running configuration. Add MAC addresses learned on the port automatically to the running configuration. So this is a sticky switch port security. First, enable port security. Enter. Now configure a sticky switch port security. MAC dash address sticky. Okay. To learn automatically to the RAM or running config. And now configure the following security settings. Okay, on fast Ethernet 18, maximum number of addresses 2. For security, maximum 2. Violation protect. Space violation protect. Aging time 60 minutes. Aging time 60 minutes. And then exit or end to go privilege exit mode. And now enable port security. Port security MAC address sticky to learn MAC addresses automatically and place to running configuration RAM. Okay, maximum number of MAC addresses 2. Okay, 2 MAC addresses maximum on fast Ethernet 18. You have only one for now, and the maximum is 2. If this maximum number is exceeded, a violation will occur, and the action is protect. The action protect drops all the packets from the insecure host, but does not increment the security violation count. Okay, the difference with restrict will increment the security violation count, but protect will not increment the count. Okay, aging time 60 minutes. And now verify. Show port security interface faster than 18. Enter. Port security enable, status up but secure. Violation mode protect, aging time 60 minutes, aging type absolute, maximum number of MAC addresses 2, total MAC addresses 0. Okay, for now 0. On real app you should have 1 MAC address learned. Okay, last source VLAN, no MAC address, no VLAN. On real app you should see a MAC address and VLAN 10, but generate traffic from PCB to simulate a real lab. And go to PCB and desktop and DHCP. Now you got the IP parameters from DHCP server, that is R1, and you generated traffic between R1 and PCB. And now repeat, show port security interface faster than 18, and you will have total MAC addresses 1, sticky MAC address 1. Okay, and last source address, MAC address and VLAN 10. This is the MAC address of PCB and VLAN 10. A sticky MAC address. Now you are using a sticky method. On S1, the configuration was a dynamic, okay, by default, no sticky MAC addresses, okay. Okay, one MAC address, but is dynamic configuration, dynamically learned. But on S2, the method is sticky MAC address one. Okay, and also show port security address. Show port security address. Enter. Now, and you will see VLAN is 10, MAC address of PCB, type secure sticky, because it's not dynamic, it's sticky. Port for satellite 18, remaining age, no information. Okay, very good, no information. Also on real lab, no information. Aging time, remaining age in minutes, no information. Why? Because this switch does not support the port security aging of sticky secure addresses. Okay, very nice. Implement DHCP snooping security. On S2, only S2 enable DHCP snooping and configure DHCP snooping on VLAN 10. Okay, click on S2, go to global configuration mode, configure terminal, IP DHCP snooping, enter, okay, and snooping on VLAN 10. IP DHCP snooping VLAN 10, enter. Configure trunk port on S2 as a trusted port. Okay. Okay, the trunk port. What is the trunk port on S2? Fast Ethernet 1 is the trunking port. And trusted port. Fast Ethernet 1 will be the trusted port. But why is the trusted port? Because it's the connection to DHCP server. Okay, the connection to DHCP server, that is R1. So this port will be the trusted port for DHCP snooping. Okay, interface Fast Ethernet 1, IP DHCP snooping trust, enter. Limit the untrusted ports Fast Ethernet 18 on S2 to 5 DHCP packets per second. Okay, what is the untrusted port? Is this the connection to a PC? Fast Ethernet 18 is the untrusted port. And access Fast Ethernet 18, IP DHCP snooping, limit rate 5 packets per second, but only packets for DHCP, 5 packets per second, 5 DHCP packets per second. Okay, exit or end and verify. Show IP DHCP as snooping. Fast Ethernet 1 is the trusted, yes. Limit unlimited. Fast Ethernet 18 trusted, no. Rate 5 DHCP packets per second. Very nice. Okay, and DHCP snooping is configured on VLAN 10. From the command prompt on PCB, release and then renew the IP address. Okay, on PCB, okay, verify the IP address. ipconfig, this is the IP address using DHCP. IP is netmask default gateway. And you can use this command, ipconfig space release command, to remove the IP address and then ipconfig and renew to get the IP parameters again. Both commands works very well on Packet Tracer, but I will not do this because Packet Tracer does not support these commands when snooping is configured on S2. Okay. And don't worry about this. On real app, you can test this and verify DHCP snooping binding using show IP DHCP snooping binding. Okay, go to S2, show IP DHCP snooping space binding. Enter. Okay, in my case, no information. Why? On real app, you should see the MAC address of PCB. You will see the IP address of PCB, the list time, and the type DHCP snooping, the VLAN, fast Ethernet 18 on S2, fast Ethernet 18, and total number of bindings 1. Okay, but this will appear, in my case, no information, but this will appear when you test these commands, release and renew. Okay, but for now, continue. Implement port fast and BPD UART. Configure port fast on all access ports that are in use on both switches. Enable BPD UART on S1 and S2 VLAN 10 access ports connected to PCA and PCB. Okay, go to S1, enter, enable, configure terminal. Okay, port fast, all access ports. On S1, all access ports are 5 and 6. Interface range, fast Ethernet 5 and 6. Spanning tree port fast. Enter. Okay, and don't worry about this big message, spanning tree port fast. Okay. Okay, and go to S2. What is the access port? Only fast Ethernet 18. Configure terminal interface fast Ethernet 18 and spanning -3 port fast. Enter. Very good. Enable BPD UART on S1 and S2 VLAN 10 access ports connected to PCA and PCB. Okay, only here on PC6 connected to PCA. On S1, okay, you can verify S1 only interface fast Ethernet 6. Spanning tree BPD UART. BPD UART enable. Enter. Then exit. S2 interface fast Ethernet 18. Now I am on interface configuration mode of fast Ethernet 18, so you can apply this spanning tree BPD UART space enable. Enter. Very good. Exit. Then verify S1 and show spanning tree interface fast Ethernet 6 detail. Enter. Now you will see the port is in the port fast mode. Okay, and also on real app you will see BPD UART is enabled. Okay, go to S2 and show spanning tree interface fast Ethernet 18 detail. Port fast mode, very good. Verify end-to-end connectivity. Okay, for example, from PCA, command prompt, and go to addressing table. First, IP address of PCB 192.168.10.11. To PCB 192.168.10.11. Okay, ping to router. Go to addressing table. Router gigabit 001 192.168.10.1. 10. Success. Ping the loopback on R1 10.10.11. Ping 10.10.1. Enter. And switch 1 ping to switch 1 10.201. Success, and now ping to S2 10.202. Success. And finally, in reference to port security on S2, why is there no timer value for the remaining 18 minutes when sticky learning was configured? Okay, go to S2 and remember this. Okay, no information on show port security address, no information on remaining age in minutes, no information, only a line. Also on real app, no information. Okay. And the answer is the switch does not support the port security aging of the sticky secure addresses. Okay. In reference port security on S2, if you load the running config script on S2, why will PCB on port 18 never get an IP address via DHCP? Okay, on S2, click here and do the following: show running config on privileged access mode, and you will see this part, fast Ethernet 18 configuration, and port security maximum 2, and you will see this MAC address sticky learned with sticky mode, and this is the MAC address of PCB. Port security is set for only 2 MAC addresses, and port 18 has 2 sticky MAC addresses bound to the port. This MAC address and a new additional MAC address. The violation is protect, which will never send a console syslog message or increment the violation counter. In reference to port security, what is the difference between the absolute agent type and inactivity agent type? If the inactivity type is set, then the secure addresses on the port will be removed only if there is no data traffic from the secure source addresses for the specified time period. If the absolute type is set, then all secure addresses on this port age out exactly after the time specified ends. Thank you very much.